This is the ANSYS video for 2D viscous flow over a flat plate at an angle of attack of 10 degrees at a motor frequency of 60 hertz. So first thing we're going to do is go to SolidWorks, sketch our wind tunnel, and sketch the dimensions of our flat plate, 0.6, 0.01, and then 10 degrees. Once you exit sketch, you hit Insert, Surface, Planar, and Save. Then we want to go back to the workbench, insert a fluid flow simulation. Right click on, well, first change geometry to 2D, then right click on geometry, import geometry. We're going to input our airfoil file. And we're going to go to edit geometry in Design Modeler. And then we are going to generate. And make sure it all looks good. No issues. Looks good. Now we can close this out. And we are going to edit the mesh. And once that is loaded in, you can click on mesh, right click, insert, method, click on the wind tunnel, and apply. Change the method to triangles. And then ideally you want it very small, 0.005 for example. Like to speed the video up, we're going to keep it as default. And we are also going to insert a sizing. Edge selector, select all 4 of these edges here. Hit apply. And while we're here, we're just going to name them as well. Hit N, call this airfoil. But now we're going to change this to number of divisions. It's fine. 100. Or you could do more if you would like. But again, speed the video up. We're going to keep that as 100. We're going to generate the mesh. Okay, make sure it looks good. Yep. Now we're going to name the velocity inlet. Just click on it, hit N on the keyboard, and then velocity inlet. Click on the outlet edge and pressure outlet. And the rest of the walls will be named walls. Okay, we are done here. So we can close out the enmesher. And then we are going to right click, hit update the mesh. Okay, once that is done, we're going to go into the setup. The setup 2D double precision, display mesh, and then hit start. Okay, once everything has loaded in to the setup, we are going to go to the model, energy off, keep it at viscous for this simulation. Make sure the fluid is air, boundary condition. We are at 60 hertz, So for the velocity inlet, or for the velocity at the inlet, it'll be around 4. Now reference values, compute that from the velocity inlet. For this, we need lift and drag. So new force support, start with drag force, printed console, and on the airfoil. And we need a lift report, printed console, lift force, airfoil. Okay. Now those are there. We go to initialize, hit initialize. Once that is done, we can go to run calculation. Change this to about 150. You could do less, you could do more, depending on what your needs are. Then we hit calculate. Okay, once that is done, we'll just take a look at our reports here. They look good. Okay, we can exit out of here. Now we can go to edit results. Once everything is loaded in, we can insert a velocity vector, symmetry 2, apply. And then, whoops. There you can go file, say picture. We are also going to insert a pressure contour at symmetry 2, apply. And then we are also going to insert a streamline surface symmetry 2, put this up to like 75 or so. That's how that looks. You can just kind of tweak this to how many or how few you want. And that's what that looks like. Oh, yeah, that is it. That is it for lab 3, part 3.